Okay, so in the last video we talked a little bit about how to chain inequalities together. That, of course, kind of presupposes that we can somehow create our inequalities. So last time we talked about inequalities, we talked about how less than or equal to, it means that A is either less than B or A is equal to B, and similarly greater than or equal to is defined similarly. So we're going to just note a couple of ways that we can manipulate inequalities in order to get different inequalities. So the first thing is if you have A is less than or equal to B, then you can add C to both sides and get this, and that is a fine thing to do. It doesn't have to be less than or equal to. This could have been any inequality symbol. The only important thing here is that we use the same inequality symbol both in the hypothesis and in the conclusion of what we're claiming here. The other thing to note here is we're basically saying you can always add something to both sides and it'll still be true. You can also subtract anything you want and it'll still be true, and the reason for that is because we don't have any conditions on C here. So if C was, say, negative C, then that's the same as just subtracting C. So basically, you can add or subtract things to both sides of an inequality. You'll get a new inequality that will still hold. Okay. Multiplying and dividing things are a little bit trickier, though. So if A is less than or equal to B, and we're going to imagine that we're going to multiply both sides by C and figure out what conclusion follows. So if C is strictly positive, then the inequality stays the same, and you can verify this with small examples if you want to. If C is negative, then AC is greater than or equal to BC. If you want to justify this, you can kind of play around with it, and like multiplying by -1 puts you back up in this case. And so you could imagine like A less than or equal to B. If you subtract both B and A from both sides, you get that negative B is less than or equal to negative A, which basically, if you just rearrange that, that's the same as flipping the sign for multiplying or dividing by -1. Point being, if you multiply by negative numbers, you have to flip the sign. And finally, if your number is neither positive nor negative, then it is 0, and multiplying by 0 just flattens everything, it makes everything 0. Okay, so that's all well and good. So that covers multiplying inequalities by a number. What about dividing? Well, this is the same kind of thing. If you want to divide by a number C, that's the exact same as multiplying by 1 over C. And of course, there's a check here that you need to do that you're not doing C equals 0, but otherwise, you can do the same thing, and dividing by C, you just keep the inequality the same. If C is positive, you flip the inequality if C is negative, and C can't be 0. You can't divide by 0. Okay, so all this is to say is that some operations preserve inequalities and some don't. So like adding, subtracting, and sometimes multiplying and dividing preserve operations. Some operations will like flip it, and some will completely turn it into equality. So some operations, things like 2 to the n, if we raise like A less than or equal to B, if you raise 2 to the power of both of those on both sides, that does actually imply that you get this result. But not all operations do this. So for instance, if instead of doing 2 to the thing, you take the thing to 2, like A less than or equal to B, that does not imply that A squared is less than or equal to B squared. And the counterexample for that is if A is -1 and B is 0, then A is less than or equal to B. But when you square both sides, you'll get that A squared is 1 and B squared is 0. But then A squared is strictly bigger than B squared, and this statement is not true. So that's a counterexample. So long story short, if you are using an operation with inequalities, make sure that when you do the operation to both sides of the equation, that the inequality actually does still hold. Um, and that's something you need to justify if it's not one of the like kind of standard ones of add, divide, multiply, subtract. All right, that's what I wanted to say about that.